Hello, everybody. Hi. I hope you can all hear me. Just let me know if you can hear me, please. We hope that you can hear me. Just let me know in the chat. Yay. Okay, good. You can hear me. You can see me. Welcome, everybody. So the official lesson is starting at 5:30, but I'm starting 5 minutes earlier. Just I wanted to test the sound and the camera, first of all. Second of all, I just wanted to get on here and chat to you all before the lesson starts so that we can have a solid hour of electric circuits. That's very important. Hi. Very nice to see all of you. If you wouldn't mind, it would help a lot if you could share this link with your class groups, with your friends. Um, I don't know if you have WhatsApp groups or groups that you communicate to your classmates with, but if you share this with them, then we can have more people join us. We can help more people. And yes, okay. It is an hour. It's only an hour. um, Yay! Welcome to all of you who are joining for the first time. So, if this is your first time, welcome. If this is your first time seeing me, hello. I'm Miss Martins. I'm going to introduce myself again at 5:30, but please subscribe if you haven't subscribed yet. I would like to go live for grade 10. Um, okay, so I am going to try and address questions as you ask them. Please ask me any questions now because we are going to get started at 5:30. I'm so grateful for you guys. Thank you for saying that. You don't even do physics, but you're going to watch the live. Thank you. That's really, really sweet. Okay, so this is for grade 11 and grade 12. Grade 11 and grade 12. Grade 10s, if you are here, hello, but it might be a little bit difficult for you. I haven't got live plans set in stone yet, but as soon as I make those live plans, I could communicate them through my channel. So through my YouTube channel, I post a community post where I say what I'm going to be doing. You can try and watch it for grade 10. It might be a little bit advanced because we need to practice for grade 12 final exams and grade 11 final exams. Okay. So I know a lot of you are saying I need to start from the beginning. Unfortunately, because this is only an hour long, I can't start from the beginning of the topic, like as if you've never heard it before. So I can't start from scratch with electric circuits, with electricity. I'm going to be practicing past paper questions. That's the purpose of this lesson. So there are challenging questions here. Okay, I'll speak about studyclix in a moment. Very awesome platform. Yes, I will be able to save the live video. Okay. I'm so glad that your friend told you about me in term one. That is my goal, to help as many people as I can. I will also look in the chat for any recommendations or any requests, let's call them requests, on topics that we will be covering, that you would like me to cover, should I say. So let me know in the chat what lessons you'd like to see in the future, maths or physical sciences. Just let me know. I like to do lives. I want to do more in the future. Okay, so comment. I'm saying comment, write in the chat what you'd like to see, and I can go and read them a little bit later. Okay, so it's almost 5:30, almost time for me to start. Oh, thank you for saying that. I'm so glad you guys are doing well in physical sciences and maths. My goal is to continue producing more content to cover more of the work. Okay, keep letting me know in the chat what you want to see in future. And please, again, send this link to all your friends and your classmates if you haven't yet for electricity, electric circuits, live. Okay, let's do it. So, first of all, I'm going to introduce myself again. I'm seeing a lot of redox comments. I'm hoping to update my redox playlists as well, hopefully. I know that you are all writing final exams soon. Yes, I am familiar with metric marking, and I'll be making reference to that in this video, in NSC marking. Yes. Okay, right. It's 5:30, everybody. Let's officially begin. Remember to share this link with everybody. As you know, or maybe you don't know, I'm Miss Martin's physical sciences and math teacher. And let me share my screen so we can get started. Okay. Right. So I won't always be able to see your chats because what I'm seeing at the moment now is the screen that I'm going to be writing on and doing the questions on. But every now and then I am definitely going to go look at the chat. So continue asking questions, comment there what you'd like me to see, what you'd like me to do in future lessons on my channel and live lessons. Okay, how to share the live. That is a good question. I think I can't see how to share it. No, I can. Wait. I'm putting it in the chats. There. That link you share with your friends. Okay, you press the little arrow, the share arrow. Okay, so the goal for this lesson is that we are doing exam revision for electric circuits, for electricity. For grade 12s, I'm mostly focusing on grade 12s because you are all writing next week. But this lesson is also for grade 11s because the circuits, the electricity you do in grade 11, you are tested on in grade 12. We are practicing past papers. I'm going to be sharing my teacher tips, the knowledge that I have from marking matric papers. So teacher tips and tips from studyclix. Okay. So I'm also going to be addressing common errors made by students. Here's the formula sheet that you get in grade 12 for electric circuits. So screenshot this very quickly, take a picture. You won't have time to write this all down, but it's good to have this on hand. And if you can, try and do the questions with me. You don't need to take down notes. This session is recorded, so you will be able to revisit this lesson later on. Okay. I just want you to focus and watch with me. You can definitely take out a pen and paper. See if you can do it with me, but because I'm trying to fit a lot of examples in this live lesson, sometimes it will be a little bit quick. Okay. So I do want to say that these questions, not all of them are easy. Some of these are challenging. These are challenging questions. So, unfortunately, I'm not teaching the topic from scratch. I'm not going to necessarily do the basics. I'm doing past paper practice. But I do have videos on the basics, building the topic up from scratch. So just check out my channel after the lesson. The video will be saved to my channel under lives. Okay, this is electricity circuits. Okay, awesome. Let's get started, everybody. I'm going to start. Oh, I need to speak about this. Sorry, I completely forgot. The platform that I'm using to practice these past papers is called studyclix. So the reason I'm using this platform is because it's for South African students. It's for those of you that are writing NSC exams. You can use it if you're writing IEB exams. Definitely can. And I have a promo code for the full version. You can create a profile and get the free version. And with the free version, you can access all the subtopics for physics and chemistry, and you can practice at least one question per subtopic, okay, or two. If you want to unlock more questions, so I have the leveled up version, the studyclix plus version, and so I can, for example, get, I think it's 29 past paper questions on electric circuits. That is way more than you would ever need to study. It's beautiful. It's amazing. So that is the promo code if you want to check it out. I promise you it's worth it. I've had students come up to me at school telling me about this, saying that they use it, and I'm like, girl, I know, I've been using this. Okay, so you pick a subject. These are all the subjects they have. It's amazing. So for all you grade 11s, it will be a good thing for you for next year. They have all these subjects. If you have a plus membership, you can access all of this. Okay. We're going to be choosing physical sciences, obviously. Okay. Electric circuits. That's what we're doing right now. Okay, starting off with our first question. So I just want to show you something amazing. So you get the question like this. It tells you on the website like where the question's from, which year, and you do the question. You can see the question, and then you click Show Memo. Okay, do you see there? Show memo. You click show memo and it gives you the memo, but not just the normal boring memo that you get like if you practice past papers online. It gives you tips, it gives you steps, it gives you teacher tricks and tips. Do you see how it tells you how to calculate? It tells you what to do. So it's kind of like you have a little teacher there with you. It's amazing. Okay, so we're going to be doing June 2023 first. That's my May, June 2023. You find this platform on Google. Okay, just type in studyclix. Right. So it says a battery with an unknown. So this is kind of like a warm-up question. Unknown EMF and an internal resistance R. So we don't know the EMF question mark. We don't know the internal resistance, baby R question mark. Then they give me the circuit like that, and they say, calculate the reading on the voltmeter. So take a look at where the voltmeter is connected. If you want to hop on or in the chat, tell me what you think you would do. Let me know. Okay. What is the code? What's the code for? So it's basically to upgrade your membership. So you can get a free membership where you can access the practice papers, a few of them per topic, but it's to unlock everything. Okay, right. So in this particular case, how would you find the reading on the voltmeter? Let me know. How would you find the reading on the voltmeter? Let me zoom in a little bit. So what I would do, take a look at the circuit. First of all, always orientate yourself and ask yourself, what is this circuit? What's connected and how is it connected? So can you see that here, total current will flow through the battery and through A2. Total current will flow down here. And then where you see the lines split like that is where the current will split. Current splits in parallel. So what that means is some of the current goes through this branch, then the rest of the current goes through this bottom branch. Then it joins up again over here. And then once again, total current will flow through the rest of that circuit. So basically, we have this branch is in parallel with this branch. So how would we calculate the voltage on the 3 ohm resistor? Normally to calculate voltage, we need current and resistance. Yes, I know the resistance of this resistor, but I do not know the current that is flowing through that resistor. So there's 2 ways to do this. You could use ratios to help you figure out what the current would be in this branch. But I think I hope, the easier way for 8.2.1 would actually be the following. If I can figure out the voltage across this bottom branch, the entire bottom branch, the rule in circuits is that the voltage across the top branch is the same as the voltage across the bottom branch, the entire bottom branch. And that's very important. So the voltage across this green branch is the same as the voltage across this entire bottom branch. So how would we calculate the voltage across the entire bottom branch? You would do V is equal to I times R. The current flowing through the bottom branch, you can see here in blue, the current flowing through this blue branch is 1.5 amperes. So we're going to go 1.5. And what is the resistance of the entire blue branch? Not just 2, not just 5. You have to add them together. 2 plus 5. So 7. 2 plus 5. Or you can just write 7. That's okay. And I get 10.50 volts. Now again, circuit rules state that if this bottom branch, so the voltage across both of these resistors, the voltage for this entire branch, if that voltage is 10.5 volts, then the voltage across the top branch, you see there's only one resistor here. So technically the voltage across this resistor is also 10.50 volts. So it would be the same. So same voltage because they are in parallel. And just take a look at how the memo on studyclix explains it. Explains it really nicely. So it says here the voltmeter reads the potential difference across the 3 ohm resistor, but the voltage across both branches in a parallel circuit is the same. So you use the total resistance in the bottom branch, which is 7, and the current. Okay, so they explain how to do it. Next, calculate the reading on the ammeter A2. Now, what you need to notice about the ammeter A2 over here, because that ammeter is not in a branch, this ammeter A1 is in a branch. So it measures the split current. Okay. Remember the yellow current. So basically A2 would read total current. Some of that current goes through the green branch and the rest goes through the blue branch. So how would we get the total current? Well, normally to get total current, we can use total voltage divided by total resistance. I can calculate total resistance if I want to, if I want to do a calculation, 1 over RP, but I don't know total voltage. I don't know what that is. So, another way that I can get the reading on A2 is what I can do is I have the current through the blue branch, the bottom branch. If I can calculate the current through the top branch, the green branch, then all I need to do is take the blue current, the green current, and add them together. And when I add them together, that will get me total current. Because remember, current splits in parallel. Okay, this question is definitely one of the more easier-ish questions that I've prepared for today. So what I'm going to be doing now is I'm going to calculate the current through the 3 ohms. So current is equal to voltage divided by resistance. And I'm going to run out of space here because I didn't plan my space properly. The voltage across the 3 ohms is 10.5. The resistance is 3. Okay, hopefully you can follow what I'm writing there. So what that means is that 10.5 divided by 3, that gets me 3.5 amperes. So just to repeat, 1.5, let's use a different color. Let's use pink. 1.5 amperes is the bottom branch's current. 3.5 is the green branch's current. Therefore, the reading on A2, which is total current, I total, is equal to 3.5 plus 1.5, which is 5 amperes in total. Okay, let me check the chat. I haven't seen the chat in a while. Okay, let's see. Okay, I don't see much. Remember, you can ask questions, hey, in the chat. I will come check every now and then. So let me know if there's something that's not that's a bit confusing. One thing I do want to say is that your unit for current is amperes, right? So you either write out the word amperes or you write a big A. Unfortunately, in finals, we have to mark you wrong if you say amps. Okay, you're not allowed to say amps. It's not a proper unit. You have to say 5A or 5 amperes. Okay, then my next question is the power dissipated in the 3 ohm resistor. Now, as you know, let's go to the formula sheet. All of these formulas are to calculate power. We're going to pick the one that is the easiest, that makes the most sense. I just want to show you where you get your marks in that question. So if we look at studyclix's memo, they tell you exactly where the marks go. So formula, substitution, showing that you are adding the current in the top branch and the bottom branch. Okay. And then for your answer, 4 marks. Again, they give you tips and they redraw the circuits and explain it really nicely if you are struggling. Okay, so power dissipated in the 3 ohm resistor. I'm going to do this here, 8.2.3. Now, like I said, we can pick from any of the power formulae. Because I'm looking for the power in the 3 ohm resistor, I know resistance is 3 ohms. I also know that the voltage across that resistor is 10.5. We worked that out earlier. I also do know the current through that branch. The current is 3.5 amperes. So I can pretty much do any of the power formulae that I want, but the one that I chose is this one. The voltage is 10.5. Don't forget to square it. The resistance is 3. So I get 36.75 watts. Power is measured in watts. Now remember, let's take a look at my memo. You see, they do all the options on the memo for you. Formula, substitution, answer with units. Here are the other options that you can make use of depending on what you chose or which variables you wanted to work with. Okay, right. I hope that was a nice warm up for you. Okay, let's see. Yes, this live will be saved. Nice. You will still get marks if you don't specify the branch. Specifying the branch is just helpful for you to keep track of your calculations, and it does help the marker understand what you're doing. So it is recommended by final markers. We do prefer it if you do show. Okay, let us do a multiple choice question. So what's nice about studyclix is that they also do multiple choice questions. And we know how difficult multiple choice questions can be in physical sciences. This one is an easier one. I have some difficult ones coming up. But let me know in the chat what you think the answer to this multiple choice is. The kilowatt hour is a unit of, let's see, multiple choice. I will let you know when a live is coming. I definitely will. Okay, let me know what you think the answer is for this one. Comment it in the chat. Okay, I'm seeing a 50-50 split at the moment between two answers. This is always interesting. Hello. I see you are commenting and watching from Spain. That is amazing. I hope I can visit Spain sometime. That's really cool. Thank you so much for saying that. Okay, I'm seeing lots of answers. I'm seeing A and I'm seeing C as the dominant answers. Okay, let me know what you think. This always happens in multiple choice. I know there's always two that everybody's arguing between. Always two. Okay. Remember, if you haven't shared the link with your friends yet, please share it with them if you just joined us. It would really, really be awesome. Oh, hello. I see you commenting from India. That is so awesome. Thank you. Okay, let's go over this. So, the kilowatt hour. Now, they're doing this to confuse you people. They're doing this on purpose. First of all, when you see kilowatts, immediately your brain is saying that it's power. I know it. And that's why I'm seeing a lot of A answers because you're seeing kilowatt. And yes, I do agree. Kilowatt is a unit for power. That is true. But they are talking about the kilowatt hour. So kilowatt is a unit for power. So power. And then the hour. What is hour? What is that? That's a unit for time. So basically, do you see kilowatt hours? It's kilowatts multiplied by hours. It's power multiplied by time. And if you think about it, you don't even have to think that much. You can visit your formula sheet. If you have to rearrange this formula, P is equal to W over T. You know that W, another phrase or another a similar variable for energy is work or work is energy. So basically power is work done or energy transferred per unit time. So if you have to take time over the equation, if you have to multiply both sides by time, so you go power multiplied by time gives you energy. Now look here. What did we just say the unit for power was? Kilowatts. Well, it's watts, but kilowatts, that is power. Let me write it properly. Kilowatts. And time, they had hours. So kilowatt hours is actually a unit for energy. So your answer is actually C. And oopsie, let me just show you quickly. Here we go. So they tell you the answer. And normally, if you do multiple choice, if you're practicing past papers and you do multiple choice and you look at the memo, it just tells you the answer. It doesn't tell you why that is the answer. So studyclix, so you can find it on Google, like I said, this platform literally tells you why C is the answer. It gives you tips. It explains it. So you see here, it's explaining it exactly how I explained it. Okay. I hope you learned something there. Okay. No, I really appreciate everybody for commenting. Remember, it doesn't matter if you're right or wrong. That is why we're here. That's why we are together. Here's a difficult multiple choice one for you. Let's do another one. I know one of the most commented things is please do more multiple choice. So there's another one. So just take a look at that. I have to give you a little bit of time to think about that. Okay. This circuit looks wacky. It looks crazy. Okay, it really does. I understand that. Okay, it's May, June 2021. Okay, so what about that one? What do you think the answer is for that one? Good luck to the IEB students that are writing paper 1 on Monday. I hope it goes well. Hi to everyone that's just joining. Okay, what do you think of this one? What do you think the answer is here? Is there a video you'd recommend to understand the basics of circuits better for grade 11? Most definitely. So if you go visit my channel after this, you will see a lot of videos building it up from the basics. So I start with basic, and then I introduce each concept slowly. So I have a playlist on it. Okay. Okay, what do we think the answer is here, everybody? I'm going to give you another 30 seconds. I want to see if you can get this. Again, difficult stuff. Okay, are you ready? Okay, I'm seeing a lot of answers. There's a lot of team D's. Okay. Let's do it. Let's speak about what the correct answer is. So, this circuit is drawn in a weird and wonderful way. So what this memo actually does, I'm going to show you the answer. Okay? But I don't know if I should show you the answer first or if I should show you how the memo looks. I'm going to scroll past the answer quickly. There. Okay, I scrolled past the answer. I want to show you how the circuit looks, a better way to draw the circuit. That is what the circuit actually looks like. Okay, if you had to draw it nicer. So we've got two resistors in parallel, connected with one in series, but don't be confused. This branch is in parallel with this branch. This is a confusing circuit. So basically, the total current will go through the battery, total current will go here, then the current will split. So you see here, that means that there's a split in the current. Total current flows all the way here until there's a split in the current. Some of the current will flow through this branch, the rest of the current will flow through this bottom branch. However, there's another split in the current. So there's a parallel little connection within a bigger parallel connection. I don't know if that changes any of your answers, but basically what you need to understand is that they tell you in the question, let's scroll up quickly. They tell you that the reading on V1, the one at the bottom, is 3 volts. So let's go to the way that they drew it in the studyclix memo. This is a rather tricky one. They even say this. This question is rather tricky. So basically, this voltage here, let's just keep that there. This voltage is 3 volts. So what you need to understand based on what I said earlier is that the voltage across this bottom branch will equal the voltage across this top branch. So this voltage across, let's write it like voltage across bottom, is 3 volts. And then the total voltage across the entire top branch, across entire top, the whole top branch, is also 3 volts. But some of the voltage goes to this resistor and the rest goes to this resistor. So which piece? Let me label it for you so that you can give me an answer in the chat. Which piece of the circuit? Let's call this part 1 of the circuit and part 2, the little circles. Which part would get more voltage? Which part would get more voltage? This connection here or this connection here? Remember, the top branch, so basically part 1 and part 2, they split voltage, but together that entire top branch must have 3 volts. But which one, this one or this one? Which piece, piece would get more voltage? Okay, I'm seeing people say part 2 would get more voltage. I agree with you. Why would part 2 get more voltage? Because this resistor is bigger than this resistor. In actual fact, if you work out the resistance, if you had to randomly give them values, so I actually did this just to check. I said that this is 1 ohm, this is 1 ohm, this is 1 ohm. Okay? if you have to work out the overall resistance of this piece of the circuit using 1 over RP, you can try it. Overall, this piece of the circuit is 0.5 ohms. So this resistor is double the resistance of this. Okay, which means this resistor needs twice as much voltage as this parallel combination. So what that means is, again, together, part 1 and part 2 must equal 3 volts because voltage voltage in parallel is the same. So it makes sense that this, and that's why the answer is C. The answer is C, by the way. That's why it makes sense that the answer is C, because this resistor would get 2 volts and this little connection here would get 1 volt. Together, the 1 and the 2 equals 3, which is the resistance of the bottom branch. This is a very confusing question. Super confusing. Probably potentially most confusing of the day. But I hope that makes sense. Okay. So just let me know in the chat if I made some sense. Okay, they do, like I said, what's nice about this platform is they explain it really nicely. So they redraw the circuit for you, they give you an ideal layout, they explain. Like over here, they say this resistance, instead of having two in parallel like this, like if you look at the original question, these two are in parallel. Instead of having two in parallel like that, it's basically the same as having one resistor. But that one resistor has half the resistance of this resistor. So this would be 0.5 whatever ohms, and this would be 1 ohm, for example, which means that the voltage across this one would always be double the voltage across this one, because the bigger the resistance, the bigger the voltage, if you think of the formula. If this number gets bigger, if resistance gets bigger, voltage gets bigger. Okay, that was a tough one. Let's move on. Okay, here we go. This is also quite a tough one. I'm just hitting you with all the tough ones. How are we doing? Okay, it didn't make sense. You made a lot of sense. I know. Okay. So the thing is that a lot of these questions initially, when you try and do it, it wouldn't make sense. But oh, plus 2 marks. Nice. Um, yeah, it wouldn't make sense if you try and do it, but then hopefully me explaining it is helps. Okay. Electricity is on another level. Okay. It is because of the ratio of their resistances. Exactly. Okay, let's move on. So this one is May, June 2024. So it says battery EMF of 12, internal resistance of 0.2 is connected to 3 resistors. They don't tell me the value of the resistances though. Okay. Please note that there's a switch here and there's a switch here. Now, one important thing that I just actually want to make clear about circuits in general is if the main switch of the circuit is open, the main switch. In other words, if I open the switch, no current flows through the circuit at all. So this would be no current flowing. No current flowing whatsoever. What does this voltmeter read over here across the battery? What does that read? EMF. Excellent. Okay. EMF. And if I close that switch, switch is now closed, current is now flowing through the circuit. Sorry, my drawings are a little bit wonky. What does that now read? So current is flowing. What does that voltmeter now read? V external. Very good. V external. And if you take, so for example, say this is 10 volts, then V external, let's say that's 8 volts. It's always going to be less. The voltmeter decreased by 2 volts. That 2 volts is called V internal, otherwise known as lost volts. So basically, EMF is equal to your V external plus your V internal. So in this case, 10 volts, 10 is your EMF. In this case, 10 is your total to your EMF. When I close the switch and current is flowing, the voltmeter decreases to 8. It will always decrease when you close the switch. V external will always be less than your EMF. EMF is a constant, by the way, very important as well. That means that V internal is 2. Okay. As you know, to calculate V external, it's current multiplied by R external. To calculate V internal, it's current multiplied by R internal. And this is where we get the EMF formula from. You take out I as a common factor and you're left with big R plus baby R. Okay, we're going to be using this in following questions, in the questions coming. But the reason why I brought this up is because if you take a look at this specific situation, I just want you to understand that if I had to open this switch, okay, if I had to open S2, there would still be current flowing in the circuit. Opening S2 just means that there wouldn't be current flowing through that part of the circuit. Okay. If I had to open S1, what that means is that current wouldn't flow through here, but current would still flow through here. So where we open and close switches, that just disturbs where the current is flowing in that particular area of the circuit. Okay, so resistance of Ry is twice the resistance of Rx. So this is really going to help us later on in our question. How can I rewrite Ry in terms of Rx? So I'll say it again. How can I rewrite Ry in terms of Rx? Based on this sentence over here, the resistance of Y is twice the resistance of Rx. So Ry is equal to, what can I say here? Yes, 2Rx. Very good. 2Rx. 2Rx. I just want you to keep that in mind for later. So instead of saying Ry, I can say 2Rx. So double of Rx basically. Okay, just keep that in mind. It says here, when both switches are closed, the reading on the ammeter is 5.5 amperes. Okay, now, first question. I want to see what you all say in the chat. Give a reason why there's no current through RZ. So what do you guys think? Why is there no current through here? Why is the current through RZ? Why is that 0? 0 amperes. Okay. I saw because current takes path of least resistance, short-circuited, bypassed. All the current flows through the wire with no resistance. Excellent. Excellent. Well done to those people. So what happens when I close this switch? S1 is closed, S2 is closed. So the current flows like this. Current flows down here. Some of the current will flow through here. That's true. Some of the current will flow through here. Then when the current gets here, the current will always take the path of least resistance. It wants to flow through the area where there's little or no resistance, the least resistance. So it's currently being blocked, not blocked, but this resistor here is annoying. Why would you go through that resistor when you can go through there? Completely pass RZ. So it is called a short circuit. So give a reason why there's no current. Let's see what they say here. So remember, you click show memo on studyclix, and then it says here, the resistor is short circuited, or current flows through the path of least resistance, or the branch with the switch has no resistance. So well done to all of you that answered that way. Very good. Very good. Okay. Now what they're going to ask us to do is to calculate the resistor Ry. Okay, calculate the resistance of Ry. Now, how are we going to do that? What I know at the moment, if we scroll up, is that, let's write it over here. We know the EMF is 12 volts. We know baby R is 0.2 ohms. What I also know is that the switches are closed. Both switches are closed, so no current will flow through RZ. Okay. They want me to calculate the resistance of Ry. So the only two resistors, basically, guys, because S1 is closed, it's kind of like this part of the circuit doesn't exist because the current doesn't flow through it. It skips past it. Okay, so the only two resistors that exist is Rx and Ry, but I told you earlier, because of this statement, it makes more sense to call Ry to Rx. So we're looking for that resistance. So where I'm going to start, and I want you to start here if you have the option to start here. If they give you the EMF and they give you baby R, where I would start immediately. Oh, and they also give me the current here. The current, the ammeter, reading on the ammeter is 5.5. Remember, the ammeter is here. The ammeter is measuring 5.5 amperes. It's measuring total current. So I know total currents. I definitely have enough information to use the EMF formula, this one. Now you'll see where I'm going with this. You sub in the current, 5.5. The resistance, I don't know the total resistance of the circuit. Just stay with me. I don't know what it is. I know that baby R is 0.2 internal resistance, and I know the EMF is 12. What I now do is I solve. So you first say 12 divided by 5.5. This is how we solve. And we're going to get 24 over 11. And then on this side, you've got R plus 0.2. Then you subtract both sides by 0.2. And I get R as being 1,981818, and it carries on like that, ohms. Basically, in fraction form, it's 109 divided by 55 ohms. Okay, now what you need to understand is that in this formula, this R is total external resistance. Total external resistance, right? The total external resistance, because switch 1 is closed and no current flows through RZ, the total external resistance is basically just this parallel connection over here. So the total resistance is the same as resistance in parallel. That's important. The total resistance, I'll write it here for you. The total external resistance is basically the resistance in parallel. So what I'm going to now do is I'm going to use the parallel resistance formula. 1 over Rp, 1 over R1, 1 over R2. Now, very important about this formula, R1 is the resistance, the total resistance in the top branch. So in this case, it's Rx. So it's going to be 1 over Rx. Okay. And then 1 over R2. R2 is the bottom branch, the resistance of the bottom branch. It's this resistance, which I told you it's better to write it as 2Rx. So 1 over 2Rx. Because I know some people are thinking, ma'am, why can't I leave it as 1 over Rx plus 1 over Ry? This is two different variables, and I can't work with two different variables. So instead of Ry, I know that Ry is double Rx. They tell me that in the question. Yeah. Resistance of Ry is twice the resistance of Rx. So 2 times Rx. So now we have one variable. And then, like I said, in this typed little bit over here, the parallel resistance, Rp, is basically the total external resistance because there's no other resistors connected here or here. This one, Rz, we're ignoring it for now because the switch is closed and all the current goes past it. It's short-circuited. Very important. So Rp is basically that value. 1,981818. Don't round off. What we have to do now is we have to do mathematics. So when you do the maths, okay? When you do the maths, what I did is I tried to add these, or not tried, I added those fractions together. I just want to see the memo here quickly. Okay. I just want to show you so far what I'm doing. Okay, they did it slightly different to me, but we're going to get the same answer. I'll show you their memo now. But look how detailed their memo is. Look how they explain everything step by step. They tell you exactly what to do. It's really, really good. So, how do you add these fractions? Can you add them? No, because they have different denominators. Now we need to do some maths. We need to get the denominators the same. So the LCD is basically 2RX. Okay, so to make this one 2RX, what you do to the bottom after times it by 2, you must do to the top. So 1 times 2 is 2, and this one is 2RX. It already is over 2RX, so it is 1. Okay, just keep following what I'm doing. Now the denominators are the same. So it's kind of like if you have 1 over 7 plus 3 over 7. If the denominators are the same, then you can add the top 3 plus 1, 4 over 7. Do you know what I mean? I hope you know what I mean. So if the denominators are the same, you keep the denominator, you say 1 plus 3. Okay, so same thing here. The denominators are the same, 2RX and 2RX. So you keep the denominator here and you say 2 plus 1, which is 3. So the algebra here gets a little bit not nice, but it's manageable. Then to solve, the easiest way I think would be to cross multiply. Cross multiply there. So what you eventually get is if you cross multiply, you get 2RX, and then 3 times 1.9818181818 is 5,94545. Then RX, divide both sides by 2, is 2,9727727. This is a lot. This is a tricky one. Then the question said, calculate the resistance of resistor RY. So what we just got was RX. Do you see that? We just got RX. But at the beginning of the sum, right in the beginning, what we said is that RY is 2 times RX. So we said RY is equal to 2 times Rx. So 2 multiplied by 2,9727, da, 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 and we get, well, I got 5,95 ohms. That is tricky, everybody. That's a difficult one. How's everybody doing? Electricity has always been a troublemaker. Hi, everyone. Okay. How do you know which is baby R? So baby R is always going to be internal resistance. So it's the resistance of the battery, internal resistance. Okay, internal resistance. Right. Which part would you like me to repeat? Yeah, I actually agree with you, Ria. You can already see here 2Rx is equal to 5,95. Beautifully spotted. And we know that 2Rx is equal to Ry. So there's your answer, staring at you in the face already. Very good. Okay, how many marks? Excellent question. So this question is worth 5 marks. So you get a mark for your formula for resistance and parallel and for substituting in. So we called it 2R, well, we called it Rx and 2Rx, same thing. Then you get a formula mark here for your EMF formula, for your substitution, and for your final answer of RY. See, they also subbed it back in. Okay. Right. let us carry on with this question. I know that these are tricky, everybody, but I hope that you are learning something. Okay, let's see if you can do the next one. They want to know the power dissipated by resistor X. The power dissipated by resistor X. What is good to know, just by the way, is that this is recorded, so you can always go back and rewatch. This is for grade 11 and grade 12. Okay. Okay, let's carry on. So calculate the power dissipated by Rx. So to calculate the power dissipated by Rx, I think the easiest way for us to do this is for us to calculate let me just erase this. This is looking like a mess. Is for us to use the following formula. So let's say 8.3. If I want to use P is equal to V squared over R. Remember, what I'm trying to do is I want to work out the resistance, the power dissipated by resistor X. So what I need to do first is find out what is the voltage across this parallel connection, because the voltage across the top branch and the voltage across the bottom branch is the same. So the first thing that I'm going to be doing is I'm going to try and calculate what is the voltage across this branch. So V, voltage across the parallel, is equal to current multiplied by resistance. Now, I know that current splits. Some of it goes up the top branch, some of it goes through the bottom branch. But what is important to remember is that essentially the total current flows through the parallel connection. Some of it goes top branch, some of it goes bottom, but the total current does flow through that little piece of the circuit. And the total current is 5.5. That's given in the question there. Then, because I'm trying to calculate the voltage across the parallel branches, I need the resistance in parallel, which we calculated earlier. It's this number over here. 1,98. Remember, we said it's technically total external resistance, which is basically the resistance in parallel, 1,98. So it's going to be 1,98. Or you can say 1,98, 18, whatever. If you can use the non-rounded off version as well. So I get 10,89 volts, or you would get 10,90 volts if you use the non-rounded off version. Now I'm not done. Remember, what I just calculated here is the voltage across the parallel connection, which is the same as the voltage across the resistor X because it's in parallel. Voltage in for resistors in parallel is equal. So it is 10,89 squared divided by the resistance of X, which is 2,97. We calculated that earlier. Here's Rx. 2,97. That's why it is actually important to calculate that. And I got 39,93 watts. Please note that depending on where you round it off, we will accept a range up to 40 watts because you can use different power formulae, you can round off, you can use the unrounded off. So just to show you the memo here they give you all the different options. So they tell you, this is the option that I did. So studyclix, like I said, they explain it step by step how to get to the answer. Here's the range, the acceptable range. So they tell you what to do. They tell you the steps. They tell you how to calculate it. And then this is the formula. This is the version that I did. You can also use current if you want. You'll get the same answer. Okay. How's everybody doing? Hi. Okay. Good luck for business. Yeah, if you didn't get RX, that's a very good point. Um, Maquela, you're asking something very interesting because if you didn't get RX correctly, let's go back here. Let's say you got the wrong value for RX, then my recommendation is literally just, well, not like what you must do is whatever you get for RX, even if it's wrong, even if you feel like it's wrong, whatever you get, you use that in this formula in the next question. And just a tip, if you didn't know what on earth to do in 8.2 and in 8.3 you know you need Rx, you need the resistance of X, then in 8.2 you're just going to write 8.2 and you're just going to write Rx is equal to, let's say, 2 ohms. You're just going to write something. The reason why is because then you can use whatever you write there. If you don't know how to do 8.2, you can use the 2 ohms in the next question and you can still get full marks for the next question. I hope that makes sense. So just because you don't know how to do 8.2 or if you do it wrong doesn't mean you need to leave out everything. Okay, that's super important. Okay, the last question here, and then I think we can do some multiple choices because we're actually almost at the end of the lesson. Can you believe it? That is crazy. Let me just copy paste this. Okay, what we're going to do now, I'm erasing that just so we can see the diagram nicely. When both switches are now opened, the reading on the ammeter is 1.3. I want you to try this quickly, everybody. I'm going to zoom out. Hopefully you can see everything. Okay, both switches are now opened. Okay, I'm just going to write everything that you might need here. Remember, the EMF is still 12 volts. EMF is constant. So they told me EMF in the beginning, it's not going to change. It's going to stay 12 volts. EMF is constant. Internal resistance is 0.2 ohms. They tell you in the beginning, internal resistance, baby R, is 0.2 ohms. Internal resistance, like I said, is constant. So that's true. We also now have a new current, is 1.3 amperes. And just important to note that we worked out earlier what the resistance of Y is and the resistance of X. Those resistors, it will be the same. Okay, so like think of a resistor. A resistor is something that like you can detach from the circuit. You can look at the resistor and it has a certain resistor value like written on it. For those of you that have done circuit practice, you'll know that. So when you put it in this circuit, that resistor has a certain resistance. Whether you open switches, close switches, whatever, that resistance still has that same resistance value, if that makes sense. So RY, I'm just going to write here, RY is still 5,95 ohms. They say with both switches now open. So that's important. This switch is open, which means that no current will flow through here. And this switch is open, which means that no current will flow through there. What that essentially means, I hope you can tell. What that essentially means is that where the switches have been opened, so here, no current, here, no current, it has basically turned into a series circuit like that. And I think that the memo does say that. Let's just check here quickly. Yes, there. So studyclix's memo lays it out very beautifully. It basically says this is the circuit that it turns into, just like I have it there. Okay, so with that knowledge and with that information, see if you can do 8.4 quickly. I'll let you actually try it. You just joined. Oh no. Luckily, this live is recorded. Yes, it will. It is recorded and it will be on my channel. Okay. It is recorded. So let me know in the chat what you think the answer is for 8.4 once you have gotten your answer. Yes, we've spoken about internal resistance. Oh, you can't see behind my head. all the stuff here. Of course, I'll always be there for you guys. I really hope that I'm helping. Kayla, Lorato, Kanye, well done. Excellent. Okay, let's do it. So, I know some people are commenting, do we need the resistance of RZ? For this particular question, we don't, because they want the reading on the voltmeter. And take a look at where the voltmeter is connected. It's connected only across RY. It's only connected across RY. So that means we need the resistance of Y, which I have, and we need the current that flows through RY, which is 1, 3. So it's actually quite a straightforward one. The reading on the voltmeter is equal to I times R, 1, 3 times the resistance, 5,95. And the answer for that, sorry, let me scroll up. The answer for that is 7,735. You may round that off to 7,74 volts. Okay. Are you ready for more multiple choice? Oh, sorry. I keep forgetting I need to scroll here. My head is blocking it. Okay. More multiple choice. Oh, thank you. There is positive marking. Yes. So from one question to the next, there will definitely be positive marking. Nice. Okay. Let's do another multiple choice. So let me just double check where we're at. So we just did, I'm lost. We've just done that. Okay. We've done that. Aha, here's one. There we go. See if you can do that one quickly. What do you think the answer is for this one? May, June 2024 is the question. Here we go. There's the question. The diagram below represents a circuit in which all the external resistors have the same resistance. That's important. Which one of the ammeters in the circuit will have the lowest reading? Okay, so write in the chat when you think you have the answer, please. Yes, the live will be saved. Remember, you need to answer A, B, C, or D. Okay, what do you think? A, B, C, or D? Don't worry, the live it has been recorded and it will be saved. Okay, so you can access it on my channel under lives. Okay, A, B, C, or D? I'm seeing a lot of people say, let me just read here. Some people are saying A2, some people are saying A3. Remember, you need to answer with either A, B, C, or D. Okay, let's go through it. So, if you take a look at the circuits, it's a little bit of a confusing circuit once again. If I were to redraw the circuit, I would redraw the circuit like this. Battery, internal resistance, then we have a resistor here in series. Okay. A4 is here, A1 is here. Then we have a split. We have a resistor there with A2 actually. Let me write that there. This would be A2, a resistor. Ooh, I'm running out of space. And then we have a resistor, A3, and another resistor. Oh, this is a mess. That is a mess. That is a mess. I just drew a big mess. Hold on. I'm trying to draw this nicely, but I don't have space. Okay. Yeah, kind of like that. Okay. So this is A1, A2, this is A3, and this is A4. Sorry, the drawing is ugly, but I think you can kind of see what I'm saying. Basically, the total current will flow through here. The total current flows through A1 and A4. So it's definitely not A1 and A4 because A1 and A4 is total current. So it's not A1, it's not A4 because those are both total currents. Then the current splits. Some of the current goes through A2. So some of the current goes through there. The rest of the current goes through this bottom branch. It goes through both of these resistors and it goes through A3. So the question says, which one of the ammeters in the circuit will have the lowest reading? Okay. So the answer is, in fact, C. Let me show you. C. So all of the currents will flow through A1 and A4, like we said, total, all the currents. The branch with A3 has a resistance of 2R. Remember, this is R and R. So in total, it's 2R. And this resistance is R. Okay. So this pink branch has bigger resistance. So it has here 2R. And then since there's more resistance through the branch with two resistors, the current will be smaller. So A3 has the lowest current reading. So it has more resistors, bigger resistance, therefore lower currents. Current and resistance are inversely proportional if voltage is constant. Okay. I think we can do another multiple choice. I know we're going a little bit over time, but I know some people have yay, first multiple choice right. Okay. I know that we're going a little bit over time. The diagram is a mess, yeah. Ugh. The bigger current goes to the lowest resistance, 100%. 100%. Okay. I'm going to do another multiple choice. I'm sorry. I know I said I would stop at 6:30. But I'm just going to do a little bit more multiple choice if that's okay with everybody. Does anybody want more multiple choice? I did a grade 12 maths live last week. It's actually still on my channel if you want to go look. I did it on algebra. Kezia, I saw your question. Okay, some more multiple choice. Time flies when you're having fun. I love it. Yeah, and that's another thing, everybody. Please never ever leave a multiple choice blank. It's really frustrating when people leave a multiple choice blank because you, like somebody said, who said that, I just saw that in the chat now, you have 25% chance of getting it correct. So just guess. Never leave it blank. If you are desperate and you've come back at the end of the exam and you're like, oh my gosh, I don't know, and you have like 30 seconds left, and then vigilator's like 30 seconds left, literally just guess. Okay, right. Oh, the answer. Sorry, I think some people are just joining and they want to know the answer. It's C. Okay, another multiple choice. 1.8. There we go. I like doing multiple choice. It's fun. What do we think here? Multiple choice is very hard. This video will be on my channel. Yes, it'll be saved. Thank you, Chego. It'll be saved under live videos. Yeah, multiple choice is rough. I would almost leave it till later in the paper because it takes long. It kills the spirit, like we're saying. Can we do some Newton's laws? Oh, that's a good one. I do need to do Newton's laws. I do think I have a live Newton's law video recorded on my channel, though. Okay. What do we think for this one? for 1.8. Are you asking if I prefer physics or math? That's a very difficult question for me to answer. Okay, I'm seeing the answer starting to come through. I'm seeing D, C, C, B, D, D. Josh, stick around. I will give you a more difficult one now. What's the answer for this one, though? Okay, B, B, D, B, C, D, D. Okay, I'm seeing a lot of mix of answers. Okay, the correct answer is, drum roll everybody, we are doing studyclix. So what's awesome about this platform, if you only joined later, is that it is a website. You can sign up for free, but to unlock all of the past papers, you can get a full version. You can use my code, Miss M100. I'll show you again later, Miss M100. And yeah, it gives you access to all the past papers. It gives the memo and it goes in detail. So you click show memo and it shows you the memo. There it is. The answer is B. Well done to those of you that said B. Good. So let's go through it. It says voltmeter V1. So these are the study tips, the teacher tips on studyclix. It's written by teachers who mark matric finals. So voltmeter V1 measures the potential difference across the external circuit. So this here, when the switch is open, it reads the EMF. When the switch is closed, it reads V external. Okay. If you have, now take note of the question, it says when the switch is open. This is kind of like theory stuff that you have to know. When the switch is open, this voltmeter will read V external. Something else that will also read V external when the switch is open is when you attach it across an open switch. This will also read V external. Remember, when the switch is open, there's no current flowing. Sorry, not V external. Sorry, I'm going crazy. When the switch is open, it reads the EMF. It says here when the switch is open. Okay, sorry. I'm fumbling myself. I'm fumbling here. So when the switch is open switch, I think I'm just getting tired. Open switch, no currents. It measures the EMF. Okay. The voltmeter across the battery will read the EMF when the switch is open. But something else that will also read the EMF when the switch is open is any voltmeter connected across an open switch. So V3. Remember, there's no current flowing. That means that there's nothing flowing through the circuit. Something across an ammeter will never read a voltage anyway. That'll be 0 volts. And because there's no current flowing, there's no current going through this resistor. You know, V is equal to I times R. So if there's no current flowing, the switch is open, your current is 0. That means your voltage across this resistor is going to be 0 volts. So some of you might be like, ma'am, then why does, when you put it across the switch, why does that also read the EMF? Think of it like you're connecting it across the open switch, but it's basically like this wire is touching this side of the battery and this wire is touching this side of the battery. And we know that if we connect a voltmeter across the battery, it reads the EMF. So this is like theory. This is like study work. Study. So if you didn't get it, it's okay. It's more theory study work. And they do explain it here as well. Just something that you have to study. Okay, one more multiple choice question. One more, and this one is a more difficult one. Okay, there we go. Oops. Try that one quickly. Any open switch will equal the EMF. Yes, exactly. Only if it's attached to an open switch, then it reads the EMF. Can't be attached across anything else. Yep, then it'll read 0. I am consistent. I'm just tired. Luanda, don't say that. Okay. What do we think here? 1.8. I'm seeing bees. You wish you joined earlier. Princess, it's okay. The lesson is recorded. The live is recorded, and you will be able to find it on my channel afterwards. Okay. I know it feels different when you live and you get to chat and stuff, but next time. Okay, I know, Josh, you were asking earlier for a difficult question. Here it is. More difficult question. Okay, I'm seeing lots of bees. I also see Anonymous says A. I'm also seeing D's. Cosmic Aura says A. Okay, are you ready for the answer? Last second submissions. Chego says A. Okay, are you ready? Let's reveal the answer. So remember, I got this off of studyclix. You can literally just scroll down. You click show memo, and then it shows the memo. Where's my memo? Hold on. I need to go get the memo. I thought I copy pasted the memo. This is May, June 2023. I want to show you how nicely they explain with the memo. And I will try my best as well to explain. But I like showing the explanation just so you can see how nice the platform works. So there we go. There's the answer. The answer is A. The answer is A. Okay. A is the answer. Let's go over why A is the answer. So it says in the circuit diagram below, they all are identical resistors, which means they have equal resistances. The power dissipated by R1 is P. Which one of the following is the power dissipated by R2? Okay, so R2 is over here. We want to know, what is the power dissipated? Is it half? Is it a quarter? Is it double? Is it whatever? So the way that I thought about this is I know that the total current will flow through the battery, the total current will flow through R1, but then current will split. Current will split. So let's pretend the current is 1 ampere. I'm just making up numbers, okay? You can do this. I often make up. So this is a tip with multiple choice in physics and chemistry. Make up numbers and then play around and like look at the formula. So let's pretend all these resistors are 1 ohm, 1 ohm, 1 ohm, 1 ohm. Okay. The power over here, so if I had to work out power, is equal to I squared times R. So for R1, it would be 1 squared times the resistance of 1. So 1 times 1 is 1, right? Everyone okay with that? So I'm just making up numbers. So the power in this resistor is 1 watts. Now, as you should know, current splits in parallel. Some of the current goes through here, some of the current goes through here. Now, because the resistors are equal, do you agree that the current will split equally? So what that means is that half of the current will go through this resistor and half of the current will go through this resistor. So if I'm trying to work out the power in this resistor, I squared times R, it's no longer 1 ampere. It's not the total current anymore. It's half of it. Half of the current. Let's actually draw it as a fraction. Half of the current will go through R3 and we're squaring it. And the resistance is 1. So do you see that that actually gives me a quarter? So that's where the quarter comes from. So the power in the 3 ohm is a quarter watts, and in the R1, it's 1 watt. So it's a quarter of the original. And no matter which numbers you pick, you'll get the same relationship between the variables. Does that make sense, everybody? Yeah, this platform is on Google. It's called studyclix. So it's actually free. You can access it for free. And yeah, you can access it for free. You can get a free profile. You can do some past papers. But to access the full version, you can use my promo code and it gives you all of the past papers. So it is nice because it is free if you want to use the free version. It's called studyclix. So type in studyclix on Google. You can click on the link in my pinned comments. Okay, in the chats. Okay. Don't worry, Remo, the lesson was recorded. Okay, everybody. Thank you so much for joining me. That is going to be the end of the lesson. I'm so sorry for the people that just arrived. I feel so bad. I really hope that that helped. Let me know in the chat if I did help you. If there's less resistance in a parallel circuit, more current goes there. Yes. How do you tackle work energy power? So, work energy power in my mind is like sister topics with Newton's. So, um, basically, if you are familiar with Newton's, you draw your free body diagrams, you do all of those things, then it'll make work energy power a lot easier. So, it's also about listing the variables. But I do have videos on my channel about it and I give nice steps. Okay, I haven't scheduled another live yet, but I will be posting on my channel when I go live yet. So so please subscribe if you haven't. And remember to check out this platform. That was basically what I showed you. You type studyclix into Google. It's really awesome. You can use the free version and you can also upgrade it to the plus version. Okay, let me just read. It's a pleasure, everybody. Like, comment, subscribe. Yeah, all of that. You enter the promo code if you want to go to studyclix plus. So if you want to access the full catalog of past papers, you will pass tomorrow. I know you will. You've got it. Thank you, everybody. I will do grade 10 next time. So I've done 2 grade 11, 12 lessons. So I'm hoping to do grade 10 next time. Or Newton's laws. Yay! I'm glad that you now understand electricity. Okay. Thank you so much, everybody. I will be letting you know when the new live is. You can look on my TikTok or on my YouTube community posts. Okay. Thank you, everybody. I'll see you in the next one or in a video, hopefully. Thank you. Also, last thing that I wanted to say, when I end the live stream now, we must also do a chemistry lesson. You are correct. When I end the live stream now, if there's something that you, will the promo work for life sciences? Yes, it will. So the promo code gives you access to unlocking all the past papers for all the subjects that they have on their websites. Okay, so if I end the live now and you still have things that you want to ask me or comments or things that you want to suggest, you can comment on any of my YouTube videos or on my community posts. I do read literally every comment. I don't always get time to comment back. I do try, but I do read all the comments. Okay, so let me know what you want to see then. Bye, everyone. Thank you.